Green, and we started to go over this last week in class. We're finding the area of the surface consisting of the portion of the cylinder x squared plus y squared equals 1, which is within the sphere x squared plus y squared plus z squared equals 5, as well as the portions of the sphere that are within the cylinder. So you have a cylinder and you have a cap on the top and the bottom. And oh, awesome, thank you. I might have you scroll for me if that would be okay. I'll just let you know. Okay, so I kind of drew what we're looking at here. So in green we have the sphere, and this is the radius is going to be the square root of 5, and then in the blue we have the cylinder with a radius of 1, and then this red, that's that cylinder with the caps that we're finding the surface area of. And if you could scroll down, maybe get this on top. Yeah, there you go. Perfect. So this is zoomed in right here just to show you what that cap looks like. So we need to find the intersection of the cylinder and the sphere. So we know that the cylinder x squared plus y squared equals 1. So I'm going to say 1 instead of x squared plus y squared plus z squared equals 5, z squared equals 4, z equals plus minus 2. So it's going to be positive 2 for the top cap, and it's going to be negative 2 for the bottom cap. So now, with our equation that we know, what we're going to do is we're going to do two separate integrals, and we're going to first do the surface area of the cylinder, which is in blue, and then we're going to take the surface area of one of those caps, and we're going to multiply that by 2 because we have the top cap and the bottom cap. And then go to the next page. Perfect. So now this is going to be the surface area of the cylinder. So we know that x is cosine of theta and y is sine of theta. Y know r because r is 1. And then z is just going to be equal to z. We only have two variables, theta and z. Z is going to be from negative 2 to 2 because we just solved for z, so those are the bounds. And then theta from 0 to 2 pi. So I'm just going to take these three components and I'm going to write it in the vector form. And then r is going to be a function of theta and z. So now we do the partial with respect to theta, and we get this right here. We take the partial of this with respect to z, and we get this right here. And then we're going to compute the cross product of these two partials, which we get right here, which really simplifies to 1 because you get cosine squared plus sine squared, and the root of 1 is 1. And then if we scroll down a little bit more, let's get this at the top. There you go. Thank you. So there's no function given, so the f of r is just going to be 1, kind of similar to last unit when we would just be finding the area of a double integral. So we have d theta dz because those are our two variables, and we found our bounds. So our bounds for z is negative 2 to 2, and for theta 0 to 2 pi. So now we're just going to compute this. So the integral of d theta is theta from 0 to 2 pi is 2 pi. Integral of dz is z from negative 2 to 2. We're going to plug that in, and we're going to get 2 pi times 2 minus negative 2, which is 8 pi. So if you think about this, we're finding the surface area of a cylinder, but there's nothing on the top or bottom. It's just that cylinder. So we can find that using 7th grade math. So you take the circumference of one of those circles, and then you multiply that by the height, and that should be the surface area of that cylinder. So because the radius is 1, the circumference of that circle should be 2 pi r. R is 1, so just 2 pi. The height is 4. 4 times 2 pi is 8 pi. So we know that the surface area of the cylinder is right because it's actually a simple shape that we used a complex method to get. And that's what all of this is saying. So you go to this next page. So we found the first part, and now we need to find that second part, which is the two caps. So this one is a little bit trickier to find the parametrics of. It's kind of like one of the problems on the second exam where we had to find r in terms of z. Okay, so we know that this r is changing. The r is getting smaller as z gets higher. So we have this sphere equation, and it's x squared plus y squared plus z squared equals 5. X squared plus y squared is r squared. So we're going to write r squared plus z squared equals 5. Move the z to the other side, r squared equals 5 minus z squared, and r equals the square root of 5 minus z squared. Technically it would be plus and minus, but we're just going to solve for the top one and then multiply that by 2 because those caps are identical. So now we know that this is r. We know that from Cartesian to polar, that x is going to be r cosine theta. We just found r. So we're going to plug that in. So x equals r cosine theta, and y equals r sine theta, and z is z. And now it's only in terms of two variables being theta and z. So now we have that set, and if you could scroll down to the next page, please. So I just rewrote the parametrics in vector form, and then we're going to take the partial with respect to theta and the partial with respect to z, and this is just a chain rule. So now we'll take the cross product of that, and it looks really complicated, but it's nice because it really cancels out well, because this root 5 minus z squared is going to cancel with this root 5 minus z squared, and this one's going to cancel with this one. This will give us sine squared, this will give us cosine squared. So when we, if we scroll down a little bit, when we simplify, we're actually just going to get 5 minus z squared times 1 plus z squared. These z squares are going to cancel, and we're just left with the root of 5. So all of that actually simplifies real well. And if we can go down a little bit more, so now we have our bounds that we found. Z is going to start at 2 because we found that intersection of the cylinder and the sphere. It's going to end at root 5 because that's that top, that's the radius of the sphere is root 5. And then theta is going to be from 0 to 2 pi because we're going all the way around. So then we find the integral of dz is z, plug in 2 and root 5, we're going to get 5 minus 2 root 5 times d theta. Integral of d theta is theta, plug in 0 and 2 pi, we're going to be left with pi times 10 minus 4 root 5. We scroll down just a little bit more. Now we're back to that original equation where we say surface area of the cylinder plus 2 of the surface area of the caps. And plug that in, we get approximately 31.766 square units. And then just down at the bottom, what does that number mean? So that's the surface area of that cylinder with the 2 caps. So all of this is on Canvas, and I tried to write out as much as I could. So if any part of that confused you, please take a look at that and take your time. It should be relatively clear. So hope that helps.
Thanks.
Yeah, you're welcome.